everyone, this is Abdul Karim, and this is gonna be our last video for this Matlab video series. Last video we talked about the for loop and the while loop, and today we're gonna uh, give a more extended version of this example for a for loop. So let's say we're gonna try to imitate the Euler's formula. We're gonna start by uh, defining the function, gonna type function, and let's use the e prox prox. This is our output, and I'm gonna name it as approximate. And our input is gonna be in. So this is our function. This line. Now we're gonna set an initial value for the approximate. And it's gonna be 0. By initially by initializing this variable, uh, this will store the total sum as we will calculate it. We're gonna start now typing our for loop. So for the first for loop, it's gonna be for k, and it's gonna start from n to n. So this is a for loop that will start from k equal to 0, and it's gonna repeat up to k equals to n. So in each loop, we will add one term from the formula uh, of Euler's number to our sum. And inside the loop, we're gonna create the variable, a variable that's named fact, as in factorial, to store the factorial of the parent k. We're gonna start by 1, so I'm gonna type fact to 1. Oh, sorry. So now we're gonna make another loop inside the first loop. It runs from I equals 1 up to k. So up to k. And in each loop, we will multiply the fact by I to compute k factorial is equal to facts multiplied by I. This will multiply the current value of the fact by I and saves it back into fact. So after this inner loop finish, fact will equal k factorized. Now we're gonna add our term. Now we're gonna add the term 1 over k factorial to our running total in approximate. So it's gonna be e approximate plus 1 over facts. Now we're just gonna put our end for the loops. So I actually forgot to write for here. So here's our first loop. Here's our second loop. Our second loop is gonna end by facts multiplied by I. So I'm gonna just type here end, and this is our end for the first loop, and we're gonna end the whole function. So after all loops are done, approx will hold the sum of the first n plus 1 terms of the Taylor series expansion of Euler's number E. Now we're just gonna use the function. First of all, we have to save it. I'm gonna save it. Now we're gonna use the function. So all I have to do is just add a value to n, saying that it's 3. Now we're gonna use this one. Now we're gonna use this one to get the so okay, so now we have to save this file before using it. Copy this. Oh, so now let's give a value for n. Let's say it's 2. And we're gonna use this. And we're gonna just copy this and paste it here. So we forgot to type here this. That's why it keeps assigning wrong. So now we're just gonna save the file again, and we're gonna assign the value for n, saying it's 3, and now we're gonna use the function. Now by typing enter, it's now 2.66, and by adding more values, we're gonna get more accurate answers. So for example, if it's uh, approximate, let's say it's 10. We're gonna see here that's more and more, that's near more and more to the uh, exact value of the Euler's number. Now we're gonna see a new kind of while loop, which is the custom stop condition. It's used when you don't know how many loops that you're gonna need in advance. So, for example, let's see here if we make this as an add, add function, how it's gonna be? It's gonna be 10 and then gonna be 13, but it's not gonna stop. Let's see how it's gonna be. As you can see here, it's gonna be counting like this forever. So if I wanted to make it specific time, what should I do? Well, what should I do is first of all to type while 1. That means in my class that this is always gonna be true. And I'm gonna add a rule if x is bigger than 1000, for example. That's gonna that means that you're gonna make a break. So our last uh, our last number that's gonna be done in this formula is 1000. So break and then end our if decision, and then we're gonna continue normally. So let's see. Alright, as you can see here, the last number that has been done is 1000 and then 1003. 1000, since 1003 is more than 1000, then uh, the execution has been stopped. We have mentioned earlier how to plot the figures of a specific function, but now we're gonna see how to animate it. So First of all, uh, the Matlab provides some methods for animation plots, for example, using a for loop and standard plot functions. This animation can be created using repeated plotting within a loop, with each iteration showing a slightly modified plot, and that creates the illusion of movement of or change. As we know, first of all, we have to define the time and the amplitude, which is our x domain and our y domain. In our case here, we're gonna uh, draw the sine function. So our x domain, it's gonna be sequence, which is starting by 0, ending on with 2 multiple 2 pi, and our step is gonna be 0.1, and our y domain is gonna be the sine of t. So we're gonna start by creating the new figure window by just writing figure, and then we're gonna start our for loop. In our for loop, we're gonna use j as our iteration or index. It's gonna start by 1, and it's gonna be end by the length of t, of this t, which we're gonna emphasize it later. So in the figure, we have to clear the previous plot, and then we're gonna start plotting now. So as we remember, we have to, by plotting the sine wave and adding the red dots, first of all, we have to plot, and then our x domain, which is in this case t, and then our y domain, which is here y. This is uh, blue line, and our line width is gonna be 2. And since we're gonna do another plot for the red dots, we're gonna type hold on, and now we're gonna start plotting the red dots. So for the red dots, we're just gonna type plot and then t of j. Now for this, which is the x value of of one iteration, so it's gonna be starting by 0, and then 0.1, 0.2, 0.3, and so on. This is our x domain for the red dot. For the y domain, it's gonna be yj, which is uh, in this case sine of j. So suppose saying that the t is 2.3, it's gonna be sine 2.3. This is our y value uh, for the red dots. This is just some cosmetic stuff that you can change later, or you can change. And then we're gonna have to set the axis limits for the plot. So we're just gonna type axis, put our parentheses, open some brackets, and we're gonna start by x values. It's gonna be starting from 0, ending up with 2 pi. The same goes for y values now. It's gonna be starting from minus 1.5, and it's gonna be ending with 1.5 in positive. After defining the axis values or limits, we're gonna now label them. So as we can see here, the the x-axis is labeled as time, and the y label is y-axis is labeled as amplitude. And we're gonna add here a title, animation of a red dot moving along a sine wave. And we're gonna have here the pose to create the animation effect. This is our uh, in like we call it FPS. So in this case, it's just 20 milliseconds. We're gonna now run this code to make things easier. Gonna run this code. As you can see here, the values started from 0, ended up with 2 pi, and for the y-axis, it started from minus 1.5 and ended with 1.5. you just see here that the red dot has moved in a specific velocity. So let's see if we change uh, the pause thing. Let's say it's gonna be 1.5. So since it's gonna be taking much time, so it's gonna be slower now, as you can see here. It's going slower and slower. But what if we didn't use this, the clearing the previous plots? Let's see what's gonna happen. I'm gonna clear now, and I'm gonna run it. As you can see here, since the uh, for each iteration, a plot has been done. So if you didn't clear this one and this one and this one, that's gonna be all over the sine wave function. So you have to do the CLF to clear the uh, previous plots. Moving on to our next topic, which is anonymous functions. So what is an anonymous function? Basically, the anonymous function is a function that you can create directly in the Matlab command window without needing to write a separate M file. It's actually useful for quick tasks where you don't need a full function definition. So if you define an anonymous function with the variables, and later you can change those variables in the workspace, but that function does not automatically update. To update it, you must redefine the function. Let's have a quick look at this. So if you wanted to uh, use this function, all you have to do is if this if handle, and you're gonna add. So this is our name for this function that we're gonna use, and you're gonna have to type add. This is our this is our variables that you're gonna use, and then you have to type the expression. As you can see here, that this is the function that handle that you will use to call the function. This is a list of the input arguments, and you have to separate it by comma, and then you're gonna type the single MATLAB expression that defines the function, which is the expression. So let's have an example. For example, we're gonna say f1 is my function, and I'm gonna save it as uh, here's my at, and here's my x and y. And I'm gonna use the expression as x squared plus y squared. And I'm gonna just type enter. Now I'm having this handle that I can use in any command window easily without having to save it as a script file. So how are we gonna use it? All what I have to do is just type f1. Now I just code the function and put our my variables. For example, let's say that I need uh, x as in 3, and separated by comma. I'm gonna now put 4 as my second value. So the logical value that's gonna be the output, which is 3 squared plus 4 squared, which is 25, and we're gonna have it here as 25. Our next type of functions, which is function functions, or we can call it as passing functions to functions. Generally, we pass functions to other functions just to make our code flexible and reusable. Uh, Instead of writing a new averaging function for every different formula, like For example, like one for velocity and another one for sine, we can write a single function that works with any function we pass in. This is mostly powerful in the simulations, analysis, and scientific computing. And we actually have used this example of passing functions to functions in our velocity functions. So we have here our main function, which is function, which was velocity, and we had another function which is distance. So uh, instead of making another function file to find the distance of the same variables that we have, which are the initial velocity, acceleration, and time, we can just type the function of distance in the same file, and it's gonna be passed to the function that we're gonna be executing. And just as that, we had the handle function that we can uh, use a function without the need to make a function file, just by typing it in the command window. The same way we can also use a plot function. So how are we gonna use it? All we have to do is type if plot. So for example, we're gonna use the sine function. Let's write if plot, and we're gonna open our parentheses, and we're gonna do our at, and then we're gonna type our function. In this case, we're gonna type sine. Then we're gonna put comma, and then we're gonna put our limits. So for the x domain. So for in our case, let's do it as from 0 to 2 pi. So it's gonna be from 0 space 2 multiplied by pi, pi, and then we're gonna close our brackets. Okay, and just like this, by closing the parentheses, we can see here our function. It started from 0 as we typed here, and it's ended with 2 pi. Uh, there were no need to put or to store a function file or to use it. We just use the handle plot to plot this figure, and of course we can do the other things like edit the color and the dots, all of these things. Also adding the labels, X labels, Y tables, and the title. All of that, it's doable to any figure that's used in Matlab. This was our last video, and by this we have covered most of the main fundamentals of MATLAB programming. I hope you got benefited from it, and see you again.